there in the technological world, that is distributed ledger technology. And I already have given you awareness to all of you that this is going to be a very, very vital component, or you can say an element into the blockchain technology. Now let's try to understand what distributed ledger means. See, whenever we are interacting on a network or internet, right? Say like you're doing anything, say you're sending an email or a message, or transacting money from, say, Rajesh sir to Sukhinder sir, something like that. So whichever the damn operation you're doing on internet, today the thing is like you are having somebody called as server. Now server is a mainstream entity, an item or an element which is existing on internet, and that is fixing all the routines of your internet. Now, guys, let us imagine that if that server is not existing, or it is got corrupt, or somebody is stealing information from the server, what can happen to your transactions, right? Those all transactions will be get vanished. Those all transactions will be will be at risk, right? So if you want that information really remains conserved, preserved, secure, you have to adopt distributed ledger. Now, in distributed ledger, what happens actually, all the peers which are participating into a network should have the ledger entry. Every entry, every transaction which is happening will be there into the distributed ledger. So this is the mere introduction. Let us dive deep into it, what actually it has having into it. So I'll start with some of the computational background, then we'll go some of the major technology where a distributed ledger actually resides, that is blockchain, and then what sort of opportunities it provides and what is the basic structure. And then we'll go into the details of distributed ledger. Now, here's a person who come up with the idea of computation. So he has given you computer back 1936, and now in 90s we have internet. Now, once you have internet, you can exchange things remotely. Amazing, right? Amazing invention. If I have to say hello to, say, Dr. Rhituraj, who's sitting in Guwahati, I can say hello right now, and within this pluck of a second only, the message get communicated. Amazing. So this was internet, which is there in 90s, but with that, this is the threat which came. Now over here, I have an intruder or a hacker, you can say, which is stealing this information, which is exchanged between these two peers, between two nodes. Now to get rid of this peer, to get rid of this intruder, we come up with three things as far as the network security is concerned or cyber security is concerned. And those three things were data confidentiality, data integrity, and authentication. So these three technologies has emerged to provide secrecy to the information. Afterwards, now what actually is happening nowadays, say like these are the various peers, various systems which are trying to communicate with each other, and this is a centralized server, centralized setup. So if, say, an X guy have to talk with Y, so they will send the information to server, Y will log in and exchange the information from the server back over here. So this is the paradigm, this is the general paradigm which is happening. Say for example, any banking application, so you want to purchase something, say from Big Bazaar. So here is a website of Big Bazaar. So you'll go over there, deposit your money to the bank, and then bank will pay to Big Bazaar and you will be getting your goodie, something like that. So this is the centralized system, centralized paradigm which is currently running. And the major threat is like, if this system is down, if this centralized server is down, then your whole system which you have set up for making the e-marketing or e-education or e-learning will be down. So your transactions are not going to work. Now, to make more strengthy to the system, we come up with another technology. This is called as Kerberos, where we are going to third-party vendor. Say like here is a third-party vendor. So this third-party vendor having two equipments or two remedies, saying this is authentication server and this is ticket TGS server. Again, these two servers are deployed to confirm you that, hey, if you are a client, so if you want to talk to a significant server, and if you really want to identify that server, then this buddy will help you to identify that. Fine. So this is the third party vendor and the technology was Kerberos. But still the problem is, The problem is this being client talking to this server, and this server is the main point of discussion. But if this get collapsed or this get collapsed, your whole transaction system get collapsed, your entire information get collapsed. Now, how to get rid of this technology? Now, again, there are some drawbacks of existing system, like every bank has server, every governance has server. Now, let's assume that, say, like you have the entire information of MHRD, or for that sake, GST or the income tax and all those things. Then what you can do with that? And it's not a big deal to crack them, mind you. There are a number of hospital servers which are, operated without any security. So you can leak the information of the patients and maybe publicize them or whatever you can do. And there is supply chain management, which is specifically used in industries. All of them use servers. So they are having their own fallbacks when it talks about centralized servers. Now, what are the fallbacks of centralized system? These are easily prone to hack. Anybody can hack a website, or put a malicious software in your mobile phone so that he can read your pins, he can read your passwords and all those things. And they are easily installable. Then centralized systems are lead to financial crisis. Yes. So if you are a bank and I can hack your website, or I can hack your server, all the financial transactions, all the financial losses you need to bear. It may facilitate to fraudulent activities. Yes, I can shoot malwares to your system will be down, and those malwares will be entertained by your server, and your server doesn't give any subtle performance. Then high transaction cost. Yes, this is also another thing which you have to pay for. If you have to do the RTGS or the other financial transactions, you need to pay huge cost for them. So these are the drawbacks of centralized systems. Now, here comes the distributed ledger technology, the foundation of the distributed ledger technology. Now, in this setup, you doesn't have any centralized authority. In this setup, you doesn't have any centralized server. Now, here, every system is distributed. Now, if you can see, I have 4 systems, and every system is connected with each other. Surprisingly, what we are going to do in this, that every peer, that look at this, peer 1, 2, 3, 4, every peer is going to have the same entry of the database, same entry of the transactions, and every peer can be treated as the owner of this network. So this was the very foundation of distributed ledger technology, and this is the first ever research paper. Mind you guys, this conference is on research. And see how the beautiful things get out of research. And this is why all we people are talking and insisting about multidisciplinary research. Very, very important thing nowadays. So this is the first research paper which is published in 2009, and the scientist who has actually published is Satoshi Nakamoto. And very, very deceptive person he is. Still, he is not detected that actually what is the identity of Satoshi Nakamoto. But he actually given this idea of peer-to-peer networking, where everybody is the owner of the network, right? No centralized system, and every individual who's participating in the network will be the owner of the network. Now get into the details of that. Once you establish such a sort of network which is chained by various blocks, then such a network is called as blockchain. Now here we are, a very, very secure, very, very procured, and very, very severe network which can carry your information. It can store your databases, it can store your important and critical transactions which you want to save for your futuristic world. And here we are, a blockchain is there for you. Now, what is blockchain? It's shared immutable ledger that facilitates the process of recording transaction and tracking the same in the business environment. Now, when I say shared, that means every participant in this network will be owner of this network. Immutable, that means once a transaction is made, try to understand this. Once a transaction is made, you cannot afford to change it. If you are a good hacker, and if you're saying that, say, I can get into anybody's block and change the data or hack the information, best of luck, you can try. I can show you the demonstration that how critical and difficult is going to be if you want to change the information on blockchain. And since the launch of the bitcoins, the cryptocurrency, the first application of blockchain, I think it's 2010 where it came into the boom. Till now, from last 14 years, nobody has hacked a single keyword, the single line of the code. This is the achievement of blockchain. Now let's come to the distributed ledger technology. That what actually distributed ledger means. Like we used to keep the track of transaction by quoting it in a ledger. So similar sort of ledger, which is a physical ledger, which I shown over here, which is an analogy to a logical ledger or a software ledger. Similar sort of ledger will be kept by every node which is there participating into the network. So if you're saying that on this particular time, say Rajesh sir wants to have a talk with me, and that transaction is completed between Rajesh sir and me, immediately this transaction get updated in everybody's ledger. So say like you're talking about 10 lakh nodes on a blockchain, or a 10 lakh nodes on a blockchain network, which is customized by you. So every ledger occupied in every node will get updated. This is the beauty of distributed ledger. So if suppose, even if we are interacting with, suppose say somebody saying hi or hello to me, that get immediately updated. Now here the distributed ledger structure is shown. If you can see over here, node 1, node 2, node 3, node 4, node 5, all these nodes are connected with each other, and you can see these are the ledgers. These are the ledgers which are maintained by these nodes. Fine. So once a transaction say happens between node 1 and node 5, this transaction detail will be updated in everybody's ledger. Everybody's ledger. This is the beauty of distributed ledger technology. Now if this particular distributed ledger technology get updated in every nodes, so where actually it is updated, it is updated into the body of this block. So this body consisting of the list of transactions. So once a transaction is established in the blockchain, it is updated right over here. This header information is a control information, right? It's a metadata concerning to the block. We need not have to discuss much about the blocks and how they were constructed. Yeah, what is the blockchain structure and how actually distributed ledger happens over here? So if you can see, this is one block, this is second block, this is third block, this is fourth block. I think if you really want to know about blockchain technology, let's concentrate on this slide. So if this particular block consisting of these n number of transactions, these transactions are hashed. Now hash is the encryption algorithm which is operated on this information. I will show you the demonstration, the live demonstration of the same. Then the hash of this block is computed, and that is given to next block. So next block consisting of its own header, its own transaction, and the hash of the previous block. So all these three components will combine and forms a hash, and this hash which is newly formed is again given to the next block. Now the information of this own block and the hash of the previous will resemble into new hash, and that is given to the next block. Now if you're a hacker, if you want to hack something, and if you get into this block and you hack the transactions over here, then obviously the hash of this block get changed, and as the hash of this block get changed, it is not accepted by this block. So you get stuck, your transaction will be not verified, and you will be caught up over there. So it is literally impossible to hack a blockchain. That's what I'm saying. Now if you can see, in a blockchain network, there are three major components, but the pivotal is the distributed ledger. Along with distributed ledger, you consisting of cryptography as well as consensus. Now what is consensus? This is also important, but let's first of all try to understand what is cryptography. Now cryptography is converting your plain text into ciphertext. Ciphertext means a cryptic text. So if you're having hello user B, this text is converted like this, and then finally it is given to the recipient by deciphering it, decrypting it and giving into the plain text. So this is the first parameter of blockchain. Cryptography can be performed by two ways: symmetric key and asymmetric key. So symmetric key means for encryption as well as decryption, you are using same key. But for asymmetric key, for encryption and decryption, you are using different keys. So what has happened in blockchain when you're doing it? So this is suppose your plain text, which is added with a encryption algorithm, which is hash. Hash 256 is an algorithm which is used by blockchain, and then you're having your ciphertext. So everything is converted into the ciphertext. Now let's talk about distributed ledger. Now what actually it is? So let us consider, guys, that you're having four, peers, four nodes in your blockchain, namely John, Kat, Peter, and Suzanne. So suppose John is transferring 3 bitcoins. Okay. So once John is transferring 3 bitcoins to somebody, say like Kat, okay. So John transfer 3 bitcoins, John transfer 3 bitcoins, John transfer 3 bitcoins, John transfer 3 bitcoins will be updated in everybody's database. Now, the important thing is whether this particular transaction which John is doing with Cat is an eligible and legitimate transaction or not. How to finalize it? Now, this is finalized by a miner, this is validated by a miner. And then there is an algorithm which is called as consensus algorithm. Now, this consensus algorithm, what actually they do, look, this consensus algorithm, once you do a transaction, that will be validated, that will be authorized by all the nodes which are participating in the network. Unless and until all your neighboring nodes are authenticating that yes, this transaction is okay, this transaction is valid, until then this transaction is not registered in the peer nodes. So this is the beauty of blockchain. So because everybody is owner, so if say me and 2 3 other guys are forming a blockchain and I decline the transaction, I say, hey, this transaction is not accepted, then this is not going to be a legitimate transaction and it's going to get deleted from the ledger. This is the beauty of distributed ledger technology. So once a transaction is legitimate, it is eligible, it is legal, then this transaction is reflected with everybody's ledger. This is how it get updated. I can show you in the demonstration that how oftenly transactions get updated in blockchain. There's an animation, say like these are all the nodes, say these are all the nodes which are participating in a blockchain network, and see how the blocks are actually inserted with the consensus of everyone. Now let's consider this purple block which is identified by everyone, and now it is added into the network. Next, this node insert this orange block, then blue block, and it is identified by every node. They recognize it. Then red comes over here. Afterwards, green is added, recognized by everyone. So unless and until somebody gives consensus, somebody give the consent that okay, this is a legitimate transaction, we can add it. Till then, no transaction can occupy into the network. This is where blockchain becomes so very critical, and so very secure. I already talked about consensus, but let's spend a minute on consensus as well. Look, consensus is nothing but a voting system, you can say, where you can take the authenticity that whether a transaction is really legitimate or not, whether a transaction is really legal or not. And this consensus is already quoted into the smart contracts of blockchain. So wherever you form a network, you find a smart contract, and then you can establish your consensus. So these are the three vital components which are occupied in blockchain, as I told you about cryptography, distributed ledger, as well as consensus. These are various applications of blockchain. Nowadays, various governmental agencies even keeping the land records on blockchain. Now, the beauty of this land record to be kept onto the distributed ledger is that if you are occupying any land that is visible to everyone which is there onto the network, the credit history, what sort of transaction you are doing with the banks or various banks has gone for blockchain, agricultural records, even voting systems, casting votes are can be done on blockchain. Citizen services like issuing various cards or health card or something like that. In healthcare, to keep the patient's history, you can use blockchain so that it becomes secure. Insurance companies are going for that. Goods and services, especially the supply chain management sort of thing. Vaccination records you can keep on blockchain so that they becomes secure and severe. So these are various applications of blockchain and distributed ledger technology. Thank you so much. I suspect that we will go for a short demo if time permits.
Sure, sir. You can go for demo also.
Yeah. Just a second. Yeah, so I hope my screen is visible to everyone.
Yes, it is
Yeah,
visible.
just a minute. Let me arrange. Yeah, if you can see, here's a website which I'm using, Anders demo. So you can even refer that. So first ever thing which I'm going to demonstrate you that how your critical information, your sensitive information will be encrypted by using cryptography. So the algorithm which I'm using is SHA-256, fine, hash algorithm. So see, already on this blank space of your transaction, there is a hash code which is generated. If you can see this, this is the hash code which is already generated over here. But let's say I am typing something, hi, this is a demo time in conference, right? So if you can see, when I type this thing, your hash get changed. Earlier it was something else. Now it is showing 68 at the start, then C and all those things, and 579 at the end. Let me extend it by using dots only. Look at this, how the hash is changing. See this. See this, how the hash is changing. Now, this is your plain text, and what is stored in a block is this hash code. Now, even if you can insert the space, look, see this, hash is changing. So this is what is going to happen in the hashing algorithm when it's going to perform the encryption to your uh, uh, plain text. Then we'll go for block. Now see what actually the data is going to be in the block. So this is the block number, and this is the nonce, which is number utilized only once. This is the unique number which is generated separately for every block. Let's say I'm inserting some data into it. I am giving blockchain demo. So if you can see, my hash continuously get changed. Now what this hash is resemble into, this hash is made up of this plain text plus this number used only once. It's a combo of these two. And this hash actually going to get stored in your block. Now let's go to the distributed technology, distributed ledger. So if you can see over here, I have this peer. This is one machine A. Let me arrange this. And this machine A is having all these, blocks into it. This is machine B. This is machine C. So it's carrying all these blocks. Now I want some concentration over here. If you can see, I can insert some data. Hello. Now see, the hash which was earlier, look at this. These are the 4 zeros, and the previous hash of the Genesis block is 0. So these 4 0 keep on changing. I say, hi, see this. See this. Now, when this hash is changing of first block, subsequently all the hashes are changing because this first hash is linked with all the blocks. So if I'm a hacker and if I want to steal this high, then all the hashes will change and my transaction will be invalid. It is not going to get deposited in the blockchain network. So I'll be out of the chain. So best of luck if you're a hacker. You're not going to hack this. So let's try again. I'll put some data into it. My hash is changed over here. Now in second block, I put some data. See, all the blocks after second blocks are changing. And when I say mine it, let's register it. If it is a legitimate transaction, then it is get mined. Otherwise, it will get discarded. See, it turns into the green. That means whatever the transaction I say to make is mined into the blockchain. So now this transaction one of block one is the participant of my blockchain. So this is how distributed ledger technology is going to get work. Now, how the distributed ledger will look alike, see this. Just a minute. Yeah. So if you can see, these ledgers are over here. For this is peer A. These are various blocks. So these are the transaction over here. If you can see, this Darcy is doing the transaction with Bingle. Okay, and then this Eliza doing transaction with Zane. Then this Vic transaction with Lydia. Then Lady with Collie, Charles with. So whenever there is a time, all these transaction will get auto updated. Let me show you how actually that happens. Just now, if you can see over here, every block carries various transaction records, and once a transaction is legitimate, then it get recorded over here. The majority of these records are financial transactions. So if you can see, somebody's transferring these $25. So Darcy is transferring to Bingle, then $4.27, which are transferred from Eliza to Jane. So these sort of ledgers are maintained by every node which is participating into the blockchain. So this is the beauty of blockchain. And if you really are interested to know that how many transactions takes place per minute or per second even, say for that, we will go to a website called blockchain.com. Yeah, so here we are. I'll go to the wallet. Go to the exchanges. See, this is the current price of Bitcoin, Ethereum, and all the other coins which are existing in the world. And if you want to really purchase or sell them, this is what the pricing are. And this shows you how Bitcoin is trending. So we can choose any block. Yeah. So if you can see, these are the details of the Bitcoin block. This is block number 8,20,817. So this is the block number. I shown you block number in my demo, right? So this was the block number. And if you can see, this is the hash code which is generated. See, this is the hash code which is generated for this block. So all the information, the critical information, the secure information is encapsulated in this hash code. Let me go to this transaction. So this is the transaction of Bitcoin, which has already been happened. So the amount of this transaction was 6.914 Bitcoins, which are transferred, right? And here is a detail of that. What was the block ID? So this is the number used only once. The nonce I showed you, which is responsible for forming the hash. And there are many other things which I can keep on showing you. This actually are interested to show you the transactions. Okay, so these are the various details which I want to share with you people about ledger technology. I hope I touch the new horizon of technology to everyone, and all of you who wants your research to be done in this particular area. This is very hot area, and the people who are knowing about distributed ledger technologies are tremendously highly paid in the industry now. Huge requirement, and there are no people which are available working on this technology. Thank you so much, sir, for giving me opportunity to talk about distributed ledger.